electrodynamometer ammeter and a permanent magnet moving coil ammeter are connected in series. Okay, this electrodynamometer and this is PMMC, they are connected in series. Now, with a resistor and a rectifier having forward resistance and backward resistance of 50 ohms and 500 ohms respectively. Okay, there is a resistance R. Okay, and here you have a rectifier. Okay, and this is input supply. We are having rectifier here. These are not ideal diodes. He has given a resistance, a forward value is 50 ohms and resistance backward is 500 ohms. Okay, now a voltage having sinusoidal waveform and a frequency of 50 hertz, RMS value of 100 volts. Okay, supply he has given as 100 volts and 50 hertz, which is applied to the circuit. Now we have to find reading of electrodynamometer, this wattmeter, this ammeter and PMMC ammeter. We know that PMMC ammeter will measure only DC values, whereas electrodynamometer will measure AC and DC. Okay, so this is AC reading, or you can say this one, it will read RMS values, whereas PMMC will read only average values. Now we have to find this RMS current and average current. Okay, now we have to find current in forward direction as well as current in reverse direction. Since the resistance values in forward direction are 50 ohms and in reverse direction he has given it as 500 ohms. Okay, now what is total resistance in forward direction? This is 50 plus 50, which is equal to 100 ohms, whereas in reverse direction is, let us take it as RR, or you can represent it as backward resistance RB. Okay, 500 plus 500, which is equal to 1000 ohms. Now what is current in forward direction? IF is equal to Vm by RF in into sin theta, or it can also be written as, since supply voltage given as 100 volts RMS, peak voltage is root 2 into 100 by forward resistance is 100 ohms into sin theta. Okay, similarly reverse direction, or you can say it as current in reverse direction, IR is equal to root 2 into 100 sin theta by RB, that is 1000, which is equal to root 2 by 10 sin theta. Here current in forward direction is root 2 into sin theta. Now what is IRMS? IRMS is 1 by 2 pi times of integral of 0 to pi. It is current in forward direction root 2 sin theta whole square d theta, plus from pi to t pi current is in reverse direction, so root 2 by 10 into sin theta whole square into d theta. Okay, you can find this value as 0.7106 amperes. Okay, now what is I average value? I average value is 1 by 2 pi times of integral 0 to pi current in forward direction root 2 sin theta d theta, plus from pi to 2 pi, this is root 2 by 10 sin theta d theta. Okay, from this we can find this current as 0.495 amperes. Okay, now what is the reading of electrodynamometer ammeter? Electrodynamometer ammeter reads only RMS values. Okay, this is equal to 0.7106 amperes. Option D is correct answer. Now what about PMMC meter reading? PMMC ammeter reads only average values. So the value of current for PMMC ammeter is 0.495 amperes. Option C is the correct answer.
Insert the following diagram. Thevenin's voltage across VXY is. Suppose if we indicate this as VA, Vxy is nothing but VThevenians, which is nothing but Va plus 5. Here Va we can get it as Va minus 10 plus 10 divided by 5 plus Va minus 10 by 5 equals to 0. This is cancel. 2 Va minus 10 is 5. Va, here 2 Va minus 10 equals to 0. Va equals to 5 volts. Hence VThevenians is 10 volts. Hence option C is correct. Consider the following diagram. The load resistance to be connected across X and Y such that it dissipates maximum power. So, in order to find out the what resistance we need to be connected across XY in order to transfer the maximum power to that load, see, we have to convert the entire circuit into Thevenin's equivalent. So if we find out Thevenin's resistance, then we're going to know what resistance we need to be connected across the XY in order to transfer the maximum power. That is, RXY must be R Thevenins for the above circuit. So we have to calculate the RThevenians. In order to calculate the RThevenians, we need to open the independent current source. We need to short the independent voltage source. Then we will get RThevenians we will get as 7.5 ohms, which is option C is correct.